Good morning. Welcome to Natural Science and Health 6. This presentation is for preparing you for your assignments for next year. So we'll discuss the assignment quickly. And why do we need this presentation? It's one of the few chances for students to get in contact with a tutor before you start doing your assignment. It will also help discuss the questions in the assignment, especially the action verbs, what is that you are expected to do. And it will also discuss what is expected from students when answering the questions in the assignment. But this presentation is not aimed to give answers to the assignment questions. Here are some of the keywords that are used in your assignments. Analyze. When you are asked to analyze, you are expected to examine the information in detail to discover the main ideas or components and patterns or relationships. It's not just to give simple answer, but you have to go in detail. If you are asked to comment, maybe you give an answer and you are asked to comment on that answer, you need to describe something and discuss briefly by giving the positive and negative points. Another key word that is being used is to compare. When you are asked to compare, you are expected to draw a conclusion about the similarities and differences and emphasize the similarities. When you are asked to contrast, you are supposed to note the differences in drawing your conclusion, deduce, use the information provided to come up with the answers, define, give a brief meaning of something, describe. You are expected to provide detailed features of an issue or stages of a process. Discuss, give a clear description, and then argue about features by pointing out positives and negative features and arrive at a conclusion. That is what you are expected when you are asked to discuss. When you are asked to differentiate, you are supposed to point out clearly the differences between the two. This is similar to contrast. And when you are asked to explain, you are expected to describe something in detail. Identify, you are expected to recognize or name or list features. No explanation is needed. You just list or state whatever that is that you are asked to identify. When you are asked to illustrate, you are supposed to use a diagram or a certain drawing to explain something. And when you are asked to outline, you are expected to give an overview and indicate the main features of something. So these verbs, if you go to your module on page 3 to 5, you will find more of these verbs described in details. And these are some of the verbs that are used in the questions. And here are some of the general expectations from your assignment. You are expected to spell the scientific names correctly, especially the elements in the periodic table. You are supposed to remember the names of the apparatus and equipment that are used in conducting experiments. You are expected to balance the chemical equations very well. You have to write the correct equation and balance it, as well as the word equations. You are expected also to calculate the molecular mass and moles. So the questions will involve calculations involving the moles, and also the molecular mass and the atomic mass. You are expected to calculate the number of neutrons, and you are expected to draw the structure of an atom. The atom, you know the structure where you draw the nucleus with all the subatomic atoms, and the electrons in the shells, you are supposed to draw those. That is a general expectation. You are expected to know from memory the correct formulas of elements, of compounds, of equations, and recite them correctly from memory. This you need to memorize, these formulas. And you are expected to use the correct units when you do your calculations. You will lose marks if you cannot write the correct formula, if you cannot balance the equations, if you cannot write the correct units. So you need to really memorize these things, especially the units, the formulas, and do the correct calculations involving moles, molecular masses, volumes, and all the and other masses also. These are some of the selected questions. An example of some of the selected questions: you are expected to write a word equation for the reaction of dilute sulfuric acid with sodium carbonate. And here you are given an equation for copper reacting with silver nitrate, giving copper nitrate and silver. From this equation follows questions. How many moles of copper are needed to react with 3.5 moles of silver? Now, if we look at the equation, 1 mole of copper reacts with 2 moles of silver nitrate, giving 1 mole of copper and 1 mole of copper nitrate and 2 mole of silver. So now when you start with your calculation, you look at the equation. 1 mole of copper reacting with 1 mole of silver nitrate. The question is asking you how many moles of copper are needed to react with 3.5 moles of silver nitrate. Now you have to, let's rewrite this one. We have 1 mole of copper reacting with 2 moles of silver nitrate. And the question is asking if you have 3.5 moles of silver nitrate, we'll need how many moles of copper? Here we see 1 mole of copper reacts with 2 moles of silver nitrate. Now here we have, suppose here we have 3.5 moles of silver nitrate. So how many moles of copper will we need here? So you can, from this information, you can start doing your calculation and work it out properly. This is just a hint of where to start. And it's only 2 bucks. So if you have 1 mole giving 2 moles, so if you have 3.5 moles, will give you how many moles? Then you just can cross multiply. You can make this question mark an X and you multiply, then you get your answer. Then we have 2x is equal to 3.5 times 1, then it gives us 3.5. Then you work out the x. And then you get your answer there. Then we go to the second question. If 89.5 grams of silver were produced, how many grams of copper reacted? Here you have to use also almost the similar, but now you are working in masses. Then we go to the next selected question. Unlike diamond, graphite is soft and slippery. Explain why. So you go to your module, there's a structure for graphite and diamond, and their properties are also described and given there. But when you do your answers, please do not copy and paste. Give it in your own word. You can refer to the bonds in graphite and the bonds in diamond and their structures, also the molecular structure. They are different, though they have all the same number of carbon atoms, the same number of bonds, but then you see they are not, the structure is not the same. So you have to give the explanation. And here you are asked to describe a chemical or physical test for water. A chemical test, you have to describe the chemicals that you are used and what is the results. A physical test, you have to mention maybe there is a color change, like they change to blue if there is a presence of water, then you must, that is a physical test. We have the atom of potassium, 40 and 19. And when we draw, we know the first shell is always having 2. So, and the next shell, for it to be full, it must have 8. 1, 2, 3, 4, 5, 6, 7, and 8. The next one also, because we have to make up this 19. 1, 2, 3, 4, 5, 6, 7, 8. This is 18, and then we add the last shell. For potassium, it have only 1 electron in its outer shell. That's why it's in group 1. So this is what you must draw when you are expected to draw an atom. Now we work out the number. The next one is to work out the number of neutrons in aluminium atom. Number of neutrons in an aluminium atom. Let's work that out. We go to the periodic table and we look at the aluminium atom is in group. Aluminium atom is in group 3, so it have 13 as an atomic number. So now we work out from here. 13 is the number of electrons, and then we go to here. It have 27. 27. Now if we subtract 13, 27 minus 13, it gives us what? It's 1. Does it have 13? 27 or 26? This is 24. I can't see very well from this periodic table. Okay, then you need to confirm this number 27. I think it's 25. 24, 25. Let's say it's 25, but you need to confirm. Okay, now is 13 minus 25 minus 13, then it's 12. It can't be. Then it's 26 minus 13, then it's also 13. Okay, let's work with 26 because I don't have a clear periodic table. Let's say here is 26. Now 26 minus 13 is 13. So we know there is 13. This 13 means is 13 electrons, is 13 protons, and when we subtract in the nucleus, then is also 13 neutrons. But if it was 27, then we know if this aluminium atom have 27, just for example, then we have 13. 27 as a mass number. Then we subtract 27 minus 13, then it gives us 14. That means it have 14 neutrons in its nucleus, 13 protons, and 13 electrons. So you just need to, from your periodic table, you subtract the mass number, the atomic number from the mass number, and that gives you the number of neutrons. And this gives us also, bring us to the next point, the difference between the relative atomic mass and the relative molecular mass. The relative atomic mass is given the difference between the two, and the relative molecular mass and the relative atomic mass. The relative atomic mass is equivalent to the number of electrons, which is also equivalent to the number is equivalent to the number of electrons, which is equivalent to the number of protons. While the relative molecular mass is given by the number of protons plus the number of neutrons. If we have to draw an atom, if we have to draw this atom, if we look at the atom, then we see this is the atom. Here is the nucleus. The number of neutrons and the number of protons, these numbers here in the nucleus, give us the relative molecular mass. And the numbers out here in the shell, the electrons, they give us the relative atomic mass. That's how we can determine it. Sometimes we say it's a mass number, and this is atomic number. So is the relative atomic mass, relative molecular mass, which is equivalent to the mass number, and this is equivalent to the atomic number. It means the same thing. Okay, relative atomic number and relative mass number. So this one, for the molecular mass, it's given by the number of neutrons and the number of protons. And the relative atomic mass is equivalent to the number of electrons in that atom. Now the next worked example is to balance the chemical equation. We need to balance the chemical equation of sulfuric acid and sodium carbonate. Now let's look at how we can balance this equation. I need to be closer. Okay, let's say we have sulfuric acid. The chemical equation, the chemical formula for sulfuric acid, as with all acid, must have H. So we have H2SO4. This is sulfuric acid. And then we have reacting with sodium carbonate. Sodium carbonate. And it gives sodium sulfate and water and carbon dioxide. We know when we have an acid reacting with a carbonate, it gives off, okay, we have this compound, but it must, in this compound, it must always have water and carbon dioxide. So this is a generic equation. So let's rewrite this one again nicely so we can balance it out. Okay. So we have an acid, which is sulfuric acid, reacting with a carbonate. And it gives, okay, a certain compound, but in its product there must always be water and carbon dioxide. Okay, now let's write the equation for sulfuric acid reacting with sodium carbonate. We have sulfuric acid reacting with sodium carbonate, and this gives us sodium sulfate, and because it's an acid and a carbonate, there must always be water and carbon dioxide. Now let's balance this equation. Here we have 2 atoms of hydrogen and 2 atoms of hydrogen. We have sulfur, 1 atom of sulfur and 1 atom of sulfur, 4 atoms of oxygen plus these 3 is 7 atoms of oxygen on this side. Here we have 4 plus this one is 5, 6, 7. The atoms of oxygen is also balanced. Then we have 2 atoms of sodium, and we need 2 atoms of sodium here. There is only 1 atom of sodium. So we need to have 2 atoms of sodium. Oh, I think the equation form. Here we have 2 atoms of sodium, 2 atoms of sodium, 1 atom of carbon, 1 atom of carbon, and here our equation is balanced. That's how we check whether the equation is balanced. All the number of atoms on this side of the arrow must be equal to the number of atoms on this side. So here we have 2 sodium, 2 sodium, 1 sulfur, 1 sulfur, 2 hydrogen on this side, 2 hydrogen on this side. And that's how you count. When they are all equal, then the equation is balanced. So this is the end of our presentation. I hope you practice balancing these equations, drawing the atoms, the formulas, and the structures, and good luck with your assignment.